In this integral, we're planning to start by making a u substitution. And this is a classic case where we have a problematic square root, and the substitution would be like this. Let u equal square root x, and that's the same as x to the 1/2, so du is going to be 1/2 x to the negative 1/2, or 1/2 root x dx. That means I could replace dx with 2 root x du, but root x is just u, so 2u du. And of course the cosine part is going to get simpler. That's just going to be the cosine of u. The other thing I want to do right now is transform the limits of integration. So when x is equal to 0, I go back and look at my substitution here. When x is 0, u is 0. So that's nice. And when x is 1, u is 1. So my limits of integration actually come out the same, even though I've transformed my integral. So now I'm going to have the integral from 0 to 1 of cosine root x, that's cosine u, and dx has been transformed to 2u du. Now I recognize what I ended up with here as a classic integration by parts problem, where normally I would say let u equal this first part, but I already used the letter u, so it's a little bit more difficult just notationally. I'm going to have to use a different symbol besides u. So I'm going to say let t equal 2u. And that means dt is going to be 2 du. So that's the integration by parts piece that we're differentiating. We chose that piece because it gets simpler when we take the derivative. Then we're going to look at the piece that we integrate. So let dv equal cosine u du, and that means v is the sine of u. Finally, we plug into the integration by parts formula, and we get that the integral from 0 to 1 of 2u cosine u du. All right, normally I would say uv, but now I'm using a t instead of a u, so I'm going to say tv, so 2u sine u, evaluated from 0 to 1, minus the integral, and normally I'd say v du, but this time I'm going to say v dt. I'll go ahead and move up here, and I'm going to evaluate the limits of integration on this first piece as I'm writing the next line. When I plug in the lower limit, I end up with 0 times the sine of 0, and both of those pieces are 0, so that's gone. The upper limit is the survivor here, and that's going to be a 2 sine of 1. 2 sine of 1. Then for my leftover integral, I'm going to bring the 2 out in front. And the integral of sine u is negative cosine u. So I'm going to combine the minus sign with the minus sign out in front. So I end up with a plus 2 cosine u evaluated from 0 to 1. So I have 2 sine of 1, that's a spectator in this step, plus 2 cosine of 1 minus 2 cosine of 0. Well, the cosine of 0 is just 1, so I have a minus 2 on that. And that's it.